Hello everybody, thank you for joining me once again. Root Beer here with yet another math contest, a Waterloo math contest. So you guys should know the drill by now. Click the first link and you can get a copy of this contest. I encourage you to download it, try it for yourself before watching any more videos in the series. And the second link, of course, just takes you to the Csmc website. Those are the guys who make these Waterloo contests. And great bunch of people. You can go to their site and see all their other contests. They even do some computer contests as well. And you can just learn a bit more about them and the University of Waterloo in general. It's a great university. I went there. Anyway, we're here not to talk about Waterloo, but to talk about the Canadian Senior Mathematics Contest, specifically the CSMC from 2016. Okay. So it's a 2-hour contest. We can just read a little bit here. There's two sort of parts to this contest. Part A worth less than the Part B, but we just need a final answer. And you just need a final answer, you get all 5 marks. However, if you do show your work, you can get part marks in case your final answer isn't there or is wrong. B part questions, there's less of them. There's only 3 of them. They're worth 10 marks apiece, but we need to explain what we're doing. Okay, we have to justify everything. We have to prove or, just otherwise give statements that explain what we're doing, how we understand this, quote theorems that we might know if it's a geometry problem, state common notions, that sort of thing. So this sort of contest is very much bridging the gap between sort of multiple choice contests where you just care about your final answer and the more advanced written contests like the Euclid. This big scholarship paper. So the CSMC, the senior paper, it's for senior level students, so grades 11 and 12 in North America. That's the sort of age group we're looking at here. We're going to do 1 question per video as we often do, and we're going to dive in with question 1 here. So as I say, 6 questions in part A, 3 in part B. If in terms of just thinking about what we're going to do with this contest, usually A6 definitely, and sometimes A5 can take you a bit of time, so those can be hard questions. Usually B1 not hard, B2 sometimes hard, B3 is often the hardest question on there. So they're ones to give a good read at the very start, but we're going to start off with question 1 here, usually the A1 by the way, usually the easiest question on the paper. So what is the value of 1 cubed plus 2 cubed plus 3 cubed all over 1 plus 2 plus 3 squared? Okay, so this question, fairly basic order of operations. If you need to, you can grab your calculator, although hopefully you're not using your calculator for something as simple as 3 cubed. This question is really about can I do my order of operations properly? It's basically all it comes down to. I'll show you some of the things that people did do that goofed up. So let's dump into our notepad here, and we're going to get working on this question. So it was 1 cubed plus 2 cubed plus 3 cubed all over 1 plus 2 plus 3 squared. So first let's go through how to actually do this. So everything in brackets is done first. We're just going to do this very slowly. So 1 plus 2 plus 3 is 6, so we get 6 squared on the bottom. Now we do exponents, so 1 cubed is 1, 2 cubed is 8, 3 cubed 27, and 6 squared 36. So we get 36, so 1 plus 8 is 9, plus 27 is 36. 36 over 36, we get 1. Okay. So let me show you some of the things I saw people doing that were wrong. Or that I have seen people do on this question that are wrong in the past. By the way, once you get this 1, that's all you need. You just write that in the box provided in the booklet. Showing your work is great in case you goofed up. How would you goof up? Well, I'll show you some of the ways you can goof this one up. So sometimes, I see this a lot with university students, they think that if you have things being added and they're all to the same power, you can sort of pull that power out. Just like if everything here were being multiplied by 5, you can sort of factor the 5 out. This is wrong. But you can sort of do stuff like this, and then suddenly, oh, we've got the same thing on top and bottom. We got 6 cubed over 6 squared, and those cancel out to give us 6. Not the right answer. as you can see. So this is one of the reasons why you can't just pull out the power of 3 here. This is wrong. But you can see people doing that sort of thing. You can do the same sort of thing. You can expand the square on the bottom the wrong way. So the square can pop out, is something people think. This is not true. 1 plus 2 plus 3 all squared is not the same thing as 1 squared plus 2 squared plus 3 squared. I mean, we know that this is 36, whereas this on the bottom is 1 plus 4 plus 9, which is 14. So we get 36 over 14. And you can simplify that a little bit to 18 over 7. And that would be your answer, but that's still wrong. Because exponents don't work this way. Okay? I'm trying to think if there was anything else people particularly goofed on with this question. You get weird answers. A whole bunch of stuff involving powers of 6 is certainly abounds. 6 to the 5, because I think when you divide, you add the exponents, that sort of thing. I'll just do another one. I don't think we saw this in the marking room, but you can certainly see people do this a lot. So you would do the expand out like this, like we did in the last one. But they wouldn't just then simplify. They'd say, oh, okay, well, I can break that up like this. So 3 squared here. That fractions somehow work this way. Fractions don't work this way, but now, oh, that gets me a 1, and that gets me a 2, and then that gets me a 3, and so that's still 6. So still massively incorrect. You can see what they're going for, but these are just the basic mistakes for people who, I find it doesn't so much happen with high school students, but it tends to happen with university students who haven't done math for a while. And they sort of vaguely remember things can factor out, and how do I find university students have so much trouble with fractions, which is a grade 4 level concept. And they do things like what I just showed you, is split up the base, like the denominator, as well as the numerator. And that's just not how fractions work. 6 by far was the most common mistake answer, I believe, for this question. Anyway, we've gone very far afield. We really only needed to do that question and get our answer of 1, but I showed you some of the mistakes that could happen, and sincerely avoid those. Those are like the worst things you can do. Okay, that's question number 1. In the next video, we'll take a look at question 2. If you haven't already, download a copy of the contest, first link in the description, and try question 2 before watching the next video. But that said, I'll see you guys next time.